All right, so right now is your midterm, right? So today was optional as far as the lecture goes. We'll just be doing an old midterm here from last spring as a kind of a review. So your actual midterm is open and it's ready to go. You can download the files as of midnight this morning. Looks like nobody has submitted anything yet, but you can of course start right now if you want to. If you're watching the live stream, go ahead and start and play this in the background or something. But otherwise, it is due at midnight. It's worth 100 points. Same format as exam one. You've got a hand in. Again, we are having lecture here. Regular help hours will be held today throughout the day, but they won't be able to give you the same amount of help as they would on a lab and a hack. Okay. So any questions first of all? No? Okay. Well, then here's the midterm from last spring. We've got a program here. We kind of did something like this before, I think, or maybe it was in the other section, where we've got one function to convert from joules into three other measures of energy. 1 joule is so many calories, 1 joule is so many BTUs, British thermal unit, pound force here, et cetera, et cetera. Then we've got a bunch of functions that operate on vector or on arrays, and so we can do whatever we want, however many we want here. And of course, since this was not the honors course last semester, there's no Java here, but we could go ahead and take any one of these and do a Java version of it. So do we want to start with this first program here, the Joule program? Yes? No? Okay, let's do it. So I'll just call it midterm touch, midterm dot. I'll put all the files, all the functions in the same files for midterm.c and touch midterm test.c. This is very much what you're going to be doing in your own midterm here, where you just put everything into these files called midterm. All right. So if I've got this, let me go ahead and cut and paste this over here. Remember what the intention of this is, that we're going to convert joules into the other three values: calories, BTUs, and foot-pound force. Okay. With a prototype, of course, we would need to provide some documentation here, right? So to do document, right? I'll just go ahead and leave it as that, right? We're going to want to also make sure that we're returning an error code here for any errors. For example, joules, right? What would be a bad value for energy? Can you have negative energy? No, you can have negative relative energy, right? Where it's going from a high energy system to a low energy system, and so you're taking energy out of that other system, but in general, no. Right? What about calories, BTUs, and foot-pound force? What could go wrong with those kind of variables? Oops. What kind of variables are they? Yeah, pointers. So what could go wrong with pointers? Null, right? So we will do error handling first. Let me go ahead and go over here to midterm.c. And the first thing I need to do, of course, is include my midterm.h, right, the header file. I will then define this function. Right? Again, the first thing that you take care of in a function is its error handling. And the first of the first is going to be those null pointer checks. So if calories is null, or BTU is null, or foot-pound force is null, then all of these are error conditions, and I will return some non-zero error code here. If you want to, you can come back and make a proper define macro, or you can come back and make a proper enumerated type to do this. For now, I'm just going to go ahead and leave it like this. Else if joules is negative, then that's a different error code, say return 2. Okay? Otherwise, we'll do our work here, but don't forget error handling in the case that there is no error. Make sure that you're returning 0 at the end. Okay? With the midterm having 3 functions methods, how do you want us to do the split between submitting them in C and Java? Read all the way to the end because you repeat all 3 of them in Java. And of course, the Java version of this would be very, very different. Why? You can't pass in by reference here, right? So the 3 functions that we give you for your actual midterm, at the end of the midterm, at the bottom of the midterm, we hopefully canvas. All right, reset student. Come on. All right, leave student view. Hopefully I put up the right handout. Midterm handout 155h.pdf, and it's all the way at the end. Yep, the Java methods. There you go. Just wanted to make sure that that was actually there. Okay. So anyway, they would all be very, very different because we don't have pass by reference variables. We don't have pointers in Java, right? But in C we can, right? In C we can go ahead and convert from joules to calories, right? How do I do that? Well, 1 joule is equal to that many calories. Let me go ahead and cut and paste that. So if I've got a certain number of joules, right, times 0.239 blah, 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 right? That's the number of calories. Is this correct? Calories is equal to that. Is that correct? The thing on the left-hand side is what kind of variable again? A pointer. Right? The thing on the right-hand side is not a pointer, it is a value. So what do I need to do to the pointer to make it into a regular old variable so I can set it? Dereference it. Okay. Same thing for BTU is equal to joules times whatever. What was it? This. There we go. And finally, foot-pound force, right? Yeah, foot-pound force is 1 joule times that. There we go. Now that I've got that, let's go ahead and go into our midterm test here. Now, test as in like, it's not the exam, it's my tester, right? We provided one for you so that you could test your functions. So we typed out all the boilerplate stuff for you already, std lib, stdio, and finally, of course, you want to include midterm.h. You wouldn't hand this in though, int main, int argc, char argv, right? In fact, I think you can't hand this in. Right? It's just for your own testing purposes so that you can actually debug, okay? But let's go ahead and create some variables here. In the handout, we usually give you at least one example. I don't know, let's just go with 10. I guess there's no example here. All right, so let's suppose that we have joules of 10 joules. And we want to convert that to the other 3. So let's go ahead and test that. What was the other 3? Joules, BTU, calories. BTU and foot-pound force. There we go. And I want to call that function, which is called convert joules. Right? Int code. I'll go ahead and capture the code as well. Convert joules from joules to calories. Oh, here. Oops. Save some typing there. There we go. Is that the correct way of calling that function? The first one is passed by value, and it's a regular old variable. But calories, BTU, and foot-pound force, they are all what? They're all expected to be pointers. Are these pointers? Nope. So how do I make them, how do I take a regular variable and make it into a pointer variable so that I can pass it by reference? Ampersand. Ampersand and ampersand. There we go. Okay. Let's do some printing, printf. Calories, or percent f calories, and I'll just say it converts to percent f, the and the line. I'm just going to print them out. Doesn't have to look pretty. There we go. And let's bring all of these things together now. I will compile the midterm.c into a compiled program, a .o file. And already I'm getting a bunch of errors and stuff. Why? It doesn't know what null is. So what should I have included over here besides my header file? Where is null defined? In the standard library. There we go. Excellent. That works. GCC midterm.o along with midterm test.c. Oops. Did I not give them all? Oh yeah, that's right. Joules, and then calories, BTU, foot-pound force. There we go. So let's run this and see if we get what we want. It's just going to be a factor of 10 on all of these, right? 2.39. Let's see. Let's move this up. What were our values? 2.39. Multiply this by 10 and you get 2 zeros and then a 9. Multiply this by 10 and you get 7. It looks good to me. Right? Okay. All right. Let's write these functions. These are all going to be operating on arrays. Compute the parity. So the parity is going to be given a bunch of zeros and ones. What you need to do is you need to go through and count up the number of ones. And if it has an even number of ones, then it has an even parity, and you should be its value is 0. For example, the bit vector 0, 1, 1, 0, 1, 0, 1 has 4 ones, and so it has a parity of 0 because it's even. 4 is even. The bit vector 0, 1, 1, 1, 0, 0, 0 has 3 ones, and therefore it has a parity of 1. It's odd. Okay? Given a bit vector here, we're going to have to, of a certain size, we go through, count up the number of ones, and then put into the value here parity either 0 or 1, depending on whether or not it's even or odd. We also need to do error handling here because, of course, lots of stuff could go wrong with each one of these variables, but also, what if you gave me that something that was not a bit vector? Something that contained, I don't know, 2 instead of zeros or ones. We're going to have to return an error code that indicates that. Okay? Come back over here, and again, I won't do documentation, but you need to for your midterm. So, error handling. Let's take care of the obvious first. The first of the first is always those null pointer checks. Bit vector, if that's null, or if the parity is null. And I'll just go ahead and put everything into 1 here, or n is less than 0. Right? Then I'll return 1. Okay? Otherwise, let's go ahead and iterate through that bit vector. If it's a 0, we ignore it. If it's a 1, then we need to count it up for the number of 1s. So let me go ahead and create num 1s. Right? Now, before I even move on to count the number of 1s, am I making a mistake on line 25? Yep, what's my mistake? What value is stored in num 1s at that point? Yep, big question mark. So if you want to initialize a variable, you should initialize it. Right? You'll start at, how many 1s have you seen so far? 0. Okay? Now, for an idiomatic for loop here. For I equals 0, I is less than n, I plus plus. Okay? If bit vector of I is equal to 1, then I want to count. Then I want to increment my num 1s. Num 1s plus plus. What other check do I want to see here? What if you gave me something that was not 0 or 1? Else if. Yep, good job. Online. Initiate the num 1s. Right? Else if bit vector of I. Well, if it's equal to 0, that's okay. we ignore it. Oops. Ignore. Else, if it's anything else, right, then return, I don't know, 2, because that's an error condition here. Now, I just wrote that ignore as a placeholder. That's not real code here. How could I simplify this so that I only had one statement? If it's not equal to 0, then it's an error, right? Now, what if it's 1? 1's not an error either, but that's already taken care of by this logic up here. If it's not 1, it must be something else. And if it's not 0, then it's definitely something other than 0 and 1. And we return 2, an error code. At the end here, I should return 0 for proper error handling. And what do I put into parity now? Parity is equal to 0 if num1s is even, 1 if odd. Right? There's my pseudocode, right? So if, I could put it like this, if num1s, how do I determine if it's even? Divide by 2 and take the remainder. If the remainder is 0, then I will go ahead and say parity is equal to 0. Otherwise, I know that it's odd, and so I say parity is equal to 1. Now, is that correct? The thing on the left-hand side is a pointer. The thing on the right-hand side is not a pointer. What should I do? Dereference it. Right? Question online, what if the number of 1s is 2 and we return 2? Excuse me. How do we know if it's the answer or if it's the error code? Because in this particular case, the answer is always going to be in that pass by reference variable. Right? This is only ever an error code over here. Right? The actual parity, either 0 or 1, will be placed into this variable right here. Okay. Suggestions on simplifying this? What's an equivalent way that I could have done this? So you might have seen it before. Parity is equal to the ternary operator, right? If num1s is equal to 0, then I set it equal to 0. Otherwise, I set it equal to 1. There's even a simpler way of doing this. Actually, no. That's the way I would do it in C. I was about to say, just go ahead and set this equal to the truth or falsehood of this. That's assuming that it's going to be 0 or 1, though. Right? And definitely 0 will be false, and so that'll be okay. But true is not necessarily 1. Right? There we go. So this is the best answer. Oops. There. Right? That's the clever answer. This is the clear answer. Which one do we want? Doesn't matter. We'll go ahead and go with this. Okay. Over here in midterm test, let's go ahead and create a really quick example. And for that, I'm just going to steal what's in the handout here. Right? So int bit vector bv is equal to this. And what's my expectation here? Printf, or what was my parity? There we go. Compute parity. I won't bother with the error code here, but bit vector, and it's of size 1, 2, 3, 7. And I need to create this variable, but parity, and int parity, and print f parity is equal to %d and the line parity. Compile everything again. Uh-oh. Bit vector, not bf. Oops. If I want to create an array, I need to say that it's an array, not just one integer. There we go. Now it's all fixed. All right, 0 as we expected. Let me come back over here and test it. Ad hoc testing, right? Cut, paste, try it. Cut, paste, try something else. Cut, paste, try something else. Right? Now here, this one we should expect 1, right? Yep. So at least from the handout examples, we're good. Do we want to see that in Java really quick before we move on or not? All right, you're going to have to help me write it because, let's get rid of all this. We don't have pass by reference variables, do we? Right, so we first need to change the return type here. Oh, actually not the return type, but public public static int compute parity, right? And we don't take a const int star bit vector. We take say a list of integers. And I'll call that the bit vector. Do we need to pass in the size of the list in Java? Nope, it's built into the data structure. So do we need to pass in a pass by reference variable here for you to fill up that bucket? Well, we can't, right? There's no such thing as pointers in Java. So what we're going to have to do is we're going to actually have to return the value as the return value here. That means doing error handling a different way. In Java, how do you do error handling instead of returning error codes? You throw exceptions, okay? All right, so if the bit vector is null or if it has a negative size, well, first of all, that second one's not even possible. But if this is null, it's going to end up with a null pointer exception no matter what, right? So don't worry about it. Right? Instead, let's just go ahead and do our code. I'm going to steal the code and adapt it over here, right? None of these things are possible, or in the case that this is possible in Java, Java will take care of it for you. It'll throw a null pointer exception. Right? Let's see. Let's go ahead and take the test too. This thing. Let me go ahead and set up my test down here, my ad hoc test. Right? I want a list of integers called bit vector equals list.of. There we go. It will create a bit vector that looks like this. Right? And then I will say int parity is equal to compute parity of bit vector, or BV. There we go. And then system.out.println parity. Remember that this one should be 1 when we're done. Okay? No changes on that first line. Right? So to get the size of the bit vector, what is it? Bit vector dot size, right? I++. It's not an array, so how do I get the ith element? Get I, right? And get I. There we go. Now I'm incrementing my counter here. Great. But what do I do in the case that it's not a that it's not a valid bit vector? It contains something other than 0 or 1 here. Now before I returned an error code. In Java you don't do that. In Java you throw an exception. I'll just throw a runtime exception with a message of invalid bit vector contains, I don't know, then you can give them the value that it contains bit vector dot get I. Right? It contains something that's wrong, right? Here I'm going to return 0, and here I'm going to return 1. Now that ternary trick that I showed you, it will definitely not, runtime exception, why are you? Oh, throw new, sorry, there you go. That ternary trick that I showed you before won't even work in Java because it'll evaluate to true and false, which are not 0 and 1. Right? 0 and 1 are numbers. In Java, numbers aren't true or false. You have full Boolean variables in Java. Okay? So remember what the value of this was? It should be 1. Yay, it works. The value of the old one, which was the first one, this one, should be 0. Let me put that in there. Oops. Uh-oh. Oh, I didn't save. There we go. you get too used to over here where it auto saves on every keystroke. Over here in Eclipse it doesn't. So it worked after I saved it. Right? Let's go ahead and try to break it. Put a 7 in there. We should get an exception thrown after I save it. Don't forget to save. We should get an exception thrown here saying that it contains 7, which is invalid. Yay. All right. Okay. There's a Hamming distance, and then there are 2-bit vectors. What are we doing here? Vector multiplication. Okay. So, yeah, we've got enough time. Let's do both. I don't know if we have enough time to do them in both languages or not, but let's understand what a Hamming distance is first. So given, again, bit vectors, arrays that contain either 0 or 1, given 2 of them, the number of places in which they differ, you count up those and then you say what the number of places that they differ. That's just the count, right? So 0, 1, 1, those agree in the first 3 bits. But in the 4th bit, 0, 1, they disagree, so there's 1. In the 5th bit, they disagree, so there's 2. And then the final bit, they disagree, so 3. That has a Hamming distance of 3 between those 2-bit vectors. So all you're doing is going through 2-bit vectors and counting up the number of times that they disagree, okay? And of course, you'll want to do some error checking here as well, right? In fact, that tells me, that's screaming out to me that if I had to do error checking here for valid bit vector, and I'm going to have to do it here for valid bit vector, maybe I could write a function to do that, call that function, right, and from both of these, and then return that value, right, if there's an error, okay? Otherwise, I'll leave that as an exercise for you. There we go, Hamming distance. In fact, I think that these are the same bit vectors as before. All right, so basic error handling, if bit vector A is equal to null, or bit vector B is equal to null, or n is less than 0, or ham distance is null, I'll return an error code here immediately without doing anything else. Otherwise, for int I equals 0, I is less than n, I plus plus, idiomatic for loop here. If bit vector of A is not equal to bit vector of B sub I, then I will increment my counter, ham distance plus plus. Let's go there. So int ham distance. I won't make the same mistake that I made last time of not initializing that to 0. But what's the problem now? Can I have 2 variables named ham distance? Nope. Okay. So here's my first solution, right? I already have a ham distance variable. Let's do it this way. Is that going to work? It might. What's the problem here, though? It may or may not. Why? I've got two operations here: a dereferencing operation and then a increment. Which one comes first? If it's the increment, what are we doing? We're doing something like this, where we take the memory address, say that it's 1234, memory address 123, and we're changing what it points to. 1234 before, now it's 1235. Right? Now it's 1236. It's pointing somewhere else entirely. Does that sound right? Nope. On the other hand, if I look at my big book of operators and operator precedence, it might be this, which would be correct. In fact, if I put parentheses around it, this would be explicitly correct. I don't want to have to remember that kind of crap. Right? So what I'm going to do is I'm going to create another local variable here, int ham hd dist, or ham dist, and I'll initialize it to 0, and I will work with that local variable, ham dist plus plus, and only set the ham distance at the end here, ham dist. There we go. That avoids a whole bunch of headache, right? It avoids having to remember what the order of operations is. It avoids having to write parentheses and write them correctly. It avoids having to make an assumption about what's in this variable before you even get into this function. Because what if this variable contained 1, 2, 3, 4, right? And you didn't reset it to 0. Then you would just be incrementing, incrementing, incrementing. Garbage plus 1 is garbage. Right? So don't worry about that. Create another local variable and only deal with pointers once at the end. Okay? Return 0. Okay? Now, one thing I didn't check up here is what? Was it a valid bit vector? Right? So you can check for that really quick. If bit vector of a sub I is not equal to 0 and it's not equal to 1, or you have the same problem with bit vector b, right? B and B, then return immediately with an error code of, I don't know, 2. There we go. I'll line that up. Is my logic correct on that? Got to think about it. Pretty sure it is, but give it a second thought at least. Right? It's got to be 0 or 1. Right? So if it's not 0 and it's not 1, then it must be something else. It's not 0 and it's not 1, then it must be something else. If that happens with either one or the other, then it's wrong. Right? Let's come over here to midterm test. I'm going to go ahead and create that other bit vector. 0, 1, 1, 0, 1. Oh, is this? Okay, that's already the second one. Let's create another one here. I'll just call it AV, A bit vector. There we go. And what should the Hamming distance here be? They disagree in that bit, they disagree in that bit, they disagree in that bit. So down here, let me go ahead and call that function now. Ham dist of AV BV of size 7 with ham dist, int ham dist, and printf ham dist is equal to %d. Line ham dist. There we go. Compile everything once again. Ham distance of 3, just like the handout. Let's see what happens when we've got a 7 in there, or a 5 in there. Oops, that's not what I meant to do. A 5 up there. Now, I didn't capture the return value, so I'm not going to be able to, oops. I'm not actually going to be able to, yeah, ham distance of 0, because it was never actually set because we had error conditions up here. Let me undo those. There we go. I'm satisfied. Last one, vector multiplication. Let's do this really quick so that we remind ourselves how do we do dynamic memory in C, and then we'll go over to Java and do a Java version of each one of these. So what this is doing is it's going through and multiplying them by each other. So if you've got a vector, say, of size 5 and another vector of size 5, you go through and you multiply the first one, 2, right? And then that's the value in the resulting array. The second 2, the third 2, the fourth 2, the fifth 2, right? The pair, I should say, right? And you're creating a new vector here. It's just vector multiplication. Okay. All right. Again, write your own documentation. Oops. There we go. Over here, I actually need to define it. Oh, there we go. Basic error handling again. It's going to be if bit vector And you know what? Steal you right there. Null, null, n is null, and now there's no Hamming distance, so get rid of that. Okay. Return. Ooh, 1? So what's the return type here? Int star. Int star is a pointer. Is 1 a pointer? Nope. So what is a pointer? What is the only pointer that you could return to indicate that something went wrong? Null. There we go. All right. Otherwise, I'm going to create a new bit vector. I'll just call it C, right? It is going to be a call to malloc. How big? You want size of, well, these are integers. Right? So however many bytes an integer takes times n, that's the size of each one of those vectors. Right? Oops. There we go. For int I equals 0, I is less than n, I plus plus. Idiomatic for loop here yet again. Right? I'll return C after this is all over. C sub I is equal to, in fact we gave it in the handout here, C sub I is equal to A sub I plus times B sub I. Oops. A sub I times B sub I. There we go. That's it. Right. So let's go ahead and test this. We could test it with those two, but what will we end up with? 0, 1, 1, 0, 0, 0, 1. The multiplication would end up being the logical and that's what logical and is. It's a multiplication over a field of size 2. Anyway, let's go ahead and create two other bit vectors though for it. Int v is equal to, I don't know, 1, 2, 3, 4, 5. In fact, what we could do is we could square it. Int c is equal to a call to vector multiplication. We could go ahead and give it the same one, v and v, and it's of size 5. And then print out v. Print for int I equals 0, I is less than 5, I plus plus. Print f %d space, because I don't want to end the line here, but c sub I. So what's going to happen when I go 1 times 1, 2 times 2, 3 times 3? I'm just going to get a bunch of squares, right? So let's go ahead and see if this works to our expectation. Print f. And the line to make it pretty. Oops. What did I call them over here? Bit vector A. You know what? I'm going to go rename them A and B. A and B. That's much easier than rewriting all of them. There we go. Run it. We should get those squares. 1, 2, 9, 16, 25. Or 1, 4, 9. Can't do the math in my head, sorry. Any questions on any of this so far? No? Okay. Then let's take all of this and translate it into Java. First of all, public static int ham distance. I'm going to have to end up returning that. We're going to use list of integers as a bit vector A. We're going to use a list of integers as bit vector B. We don't need either one of these. In fact, we don't need the first one because we already know what the size is, and we don't need the second one, or we can't have the second one because it's a pass by reference variable. Okay. If any of this stuff happens, a null pointer exception will be thrown automatically. We don't have to worry about it. Right? Otherwise, we have a ham distance of 0. Right? Each one of these is going to end up being get I instead of sub I. Get I, and get I. There we go. This will also be get I and get I. N changes into bit vector dot size. Oops. A dot size. There we go. Now one thing that could happen here is that this bit vector has 5 things and this bit vector has 7 things, in which case you'll end up with potentially an index out of a bounds exception here, right? But Java takes care of that for you. If you right, it'll throw that exception automatically. There's no reason to check for it. If you wanted to check for it, you could, right? If bit vector a dot size is not equal to bit vector b dot size, then you can throw your own custom exception. Throw new runtime exception. Vectors are not of the same size. Dimension. When we talk about vectors, we talk about dimensions. Okay. Otherwise, if we don't have a proper bit vector zeros and ones, we'll throw another runtime exception with a completely different error message. Invalid bit vector. I'll just do it like that. Okay. Otherwise, we'll return hand dist. There we go. Clean it up. Excellent. Public static int vector. Actually, it's not going to be return one value now. What is it going to return? If I take 2 lists as inputs and I want their multiplication, A, B, what am I going to be returning here? Another list. So that's all taken care of by Java. Java, I don't use malloc. What do I do to create a new list? New array list. There we go. I can iterate over all the elements in A and B and return C. And C dot add A dot get sub I times B dot get sub I. There we go. And this will be A dot size. And again, you can throw the same exception down here as well, that if they're not of the same size, the vector's multiplication is not well defined, and so you throw an exception like this. Okay. Questions? We could test these, but I'm pretty sure that they're correct. All right. Let's just test the last one here. V, and what did I put in there? 1, 2, 3, 4, and 5. List of integer square is equal to vector mult of V with itself. All right, there we go. And then system dot out dot println s. There we go. And it should be, oops. Okay, fine. I'm getting an exception on that right there. There we go. 1, 4, 9, 16, 25. Okay. There's the midterm plus Java from 1 semester ago. We got it done in 45 minutes. So usually, and that was with me talking. So usually the way that I design exams is I'll make a large exam, then I'll cut it down to what I think is reasonable, hand it off to an LA. They'll do it and they'll report back how much time they took. I multiply the time that I take without talking about it by a factor of 3. I multiply the time that an LA takes by a factor of 2, and if that's at an hour or so, then it's acceptable. And that was what your that's what your midterm looks like over here. It is 3 functions in C. In fact, it's a retread of something that you've already done, right? It's just a redesign of the corn statistics redesign of the FizzBuzz, right? And another function here that's called merge. Right? Then you repeat them all in Java with slight differences. Do I still have my terminal open? 2 people have now taken the midterm in this course. So at least submitted something, maybe not all of it, but at least part of it. This is the first time I've done like a review during the midterm phase, so. Any questions? No? All right, then good luck on the midterm.